Today we are going to discuss about accelerating digital twin creation, harnessing image models for transformation. There's a lot that we want to discuss today. So the first part will be an introductory section on PowerPoint, exploring the concept of the digital twin and also what is the industry model for those that are not familiar with. And then we will jump into the demo in which we will transform the model, generating a BPMN visualization from a so-called ETON model that is a process model. We will go into a simulation so that before deploying the digital twin, we have an idea how that works. We will generate some APIs and also an application based on those APIs. And then we will connect this application with a so-called digital thread with our original model. And finally, we will show a digital twin dashboard. So there's a lot to do, and I hope I can show you all of that in 1 hour. Me, I am Gio. I am in IT since many years, and since many years I have been using Sparx Enterprise Architect, but my original passion was to apply system theory, and I started at university in the early 90s. So, and since that, I continue to be really passionate about resilience and balance of systems. And I do live in Canada in a off-grid farm. So what are we trying to solve here? So nowadays, one of the main problems that we are facing that is widely misunderstood and underestimated is managed complexity. We know that our world is more and more complex. We know that certain things appear to be easy, but behind the cover is a lot of work. And we cannot anymore simply manage this level of complexity by having a lot of people working on that, because simply we cannot talk the same language and understand what a very specialized role is doing, while another specialized role is trying to implement what they do or what they say. So, and that is a breakthrough innovation. So we want to try to accelerate innovation and to bridge silos. Like I said, a silos is created when different departments are creating different things in isolation. They don't talk to each other. And at the end, we want to achieve a agile growth. And we want to do that using those two concepts of digital twin and a industry model. So let's start with the digital twin. So what is a digital twin? A digital twin is a model representation of a complex system and describe the behavior and characteristic of that system. Think about a digital twin like a virtual replica that can be used to simulate that system and predict what the system will do even before you deploy that system. Additionally, after that the system is deployed, we can monitor the performance of that system using a special technique that we will show today called digital thread. So one of the things that people is really confused about is the scope of your digital twin. So in this slide, we have Eurocom. Eurocom is a non-existing company in the telecom space working in Europe. And we could create a digital twin of a Eurocom SCADA system. We could create a digital twin of the complete IT of Eurocom, namely multiple systems, or we could have in scope the complete Eurocom. And that is called a composite digital twin or a system of systems. And that is what we have in scope today. As you can see, it's a ambitious, goal. And clearly to achieve that, we will need some help, and we will see how an industry model can help you to realize that. Another thing is, what is a digital twin? How you know that it's a digital twin and is not a fake PowerPoint or whatever. Many people believe that a digital twin is like a video game. A lot of digital twins are presented to be 3D representation of something like a city. That may or may not be true, but this is not what a digital twin is. A digital twin is, true. So we have a litmus test for digital twin when we can execute the same test on the digital twin and the real thing and get the same result. In this example, we have a digital twin that is derived from the industry model, and we'll see in detail what that means. And then we have the physical organization, and we execute the same test, and we get the same result. So that is a good measure of having a digital twin. So, but how we do that? To build a digital twin, we need to apply something called digital engineering. So digital engineering is not a single thing, but is like merging a lot of different disciplines from engineering, 3Ds, but also from model-based software engineering and model-based system engineering. At the end, with digital engineering, what we want to achieve is use a authoritative source of system data and model so that we can reduce the amount of real activities and we can source everything in a single authoritative source of truth. So that means we have a model in which we have our information and we don't have 10 different sources of truth that are not aligned with each other and they are contradicting each other. Okay, clearly that is a super short introduction to digital twin and digital engineering. I have some other presentation on YouTube on what is a digital twin and how to apply that. Today we want also to use industry models. So what is an industry model? If our objective is to create a complete digital twin, a system of the complete enterprise or organization, we are talking about a lot of different characteristics. And if we will start from zero, that will be a huge enterprise. And some organizations are trying that, but it's much better to take advantage of an industry model. So those models are created for different industry and are structured representation of different aspects of the industry, such as components, process, entities, and you can use them in different ways. And today, I hope I can insert in your mind that that can be a key way to use a digital twin. So in this slide, we can see different type of digital industry models for different industries, such as insurance, banking, retail, supply chain, energy and utility, healthcare, and so on. And we are going to focus on the TM Forum model. And full disclosure, since 1.5 years, I am helping the TM Forum to port their content so that they are created within Sparx EA and they are consumable immediately. But that don't mean necessarily that the TM Forum yet is providing to you a model that is ready to be used as digital twin. There is some stuff that we need to do. So let's go inside and examine what is the TM Forum Open Digital Architecture, or ODA. ODA is divided in submodels containing capabilities, business processes, metrics, information, and more. We are talking about thousands and thousands of objects. So for example, in the process framework, we have over 3,000 processes that are decomposed in sub-processes. Then we have the information framework that contains around 2,000 elements of the information framework. Then we have open APIs that expose all of that. We have also business capabilities, we have metrics, and so on. So, and as I said, since 2022, this is available as Sparx EA model. So if you are in the telecom industry, consider to consume that natively, because previously that was available as a set of PDF and Excel spreadsheets, and in EA you have much more capabilities. Today we are going to show some very advanced feature that you can apply by applying a model and those concept of digital twin and digital engineering. So clearly, For the sake of the demo, we have taken a subset of information, and that is the subset that we will use. So in general, ODA, so the Open Digital Architecture of the Team Forum, is organized in domains. So you see here, that is one domain called the customer domain. And a domain is aggregating business processes. So here you see 3 business processes. And a process is measured by metrics and is creating and consuming ABEs that are aggregated business entities. Now, this model, I help out develop this model. You may see that is kind of derived a little bit from Archimate or inspired by Archimate, but really it's a custom model so that the team forum can express everything that they want to express, but it's not necessarily everything we need to do digital engineering and to create a digital twin. So we need to enrich this with a special meta model that will contain additional information that we need for the creation of a digital twin. Now, what is that we can do with such a model? There are different activities that we need to think about, such as plan, architect, simulate, transform, develop, and monitor. And those activities are performed by different people in different moments. But what is important is that all those activities are performed against the so-called source of truth or ASOT, so that we have a single traceability between the original creation of the model and its implementation as a physical organization. And we have, roles such as the architect, the engineer that creates simulation, another engineer that creates transformation. And we'll see that all those activities need to be applied in different layers of this, what I call a reference architecture. Now, as you can see, we have the same boxes of activities. On the very top, we have verticals. And that is an interesting thing if you think about it, because the difference between one company and another company substantially is the vertical. They should not necessarily have a difference in the green or blue box. They could reuse the same integration layer and the same platform layer. And I'm not saying that this specific, structure here, what you see like in the platform layer, need to be applied by everyone. But I'm saying that we need to distinguish the technology from the so-called business requirement or business description that is in the model. And then we have the integration layer in which we can create a connection between the two. So those concepts are not completely new. What is new now is that we are going to have a so-called feedback or digital thread from the platform into the model that is on the top. Another thing that I would like to point to your attention is the Eurocom box. And you see that Eurocom is our non-existing company that is in scope, and they will not necessarily adopt everything in the digital open digital architecture. So they will adopt and modify a part of it, and then they have also a part that is completely custom, and clearly that is super important for them because that is the differentiator between Eurocom and any competing company. With all in mind, let's look a little bit about toolchain. So clearly we have here in the middle the ASOT. So remember, that is the authoritative source of truth. In our example, this is going to be a EA database. We can have also other type of ASOT. And then we have our architect that is working with enterprise architect, producing and modeling things. We have a product manager that is consuming by using Prolaborate the result. And we have the executive that can monitor the result not only of the ASOT, but also from the generated artifacts that are directly generated from here, and how we, manage the technical aspect of it. On the right side, we have 3 very important technical roles. So we have a simulation engineer. Here we are using OpenModelica, that is an open source tool, EA supported out of the box For the sake of the example, we are not going to use OpenTeleCom because it's super complex. We are going to use the BPMN simulation capability of EA itself. Then we have here the model engineer that used the Eclipse space. Eclipse community had created a lot of interesting technologies for transformation of models, and we are going to use it. And then we have here the developer that is developing code so that we can use this code in the platform. That is what we have seen previously. Okay, that is all I wanted to discuss for the introduction. And now we are going to the demo. In the demo, we are going to show a lot of different things. We'll start with the customer domain processes as they are provided by the industry model. So that is a ETOM submodel. We will then generate this into a BPMN process. Then we will simulate this to simulate different scenarios, and we will evaluate the results. Then we will generate from the same ETOM model a Swagger file, so a API, and based on that API, we will generate a full-fledged Python application, and then we will use a special technology that we have developed at Door Business Consulting to connect the model, the EA model, directly with an API. That is something completely new, and as far as I know, that has been never demonstrated before. So let's start in our demonstration. So when you import your model, the TM Forum model, into your own repository, this is what ETOM looks like. I have color code a little bit the processes, but you see we have here domains that are like horizontal ways to shape things. And then very important for us, we have the verticals, such as strategy management, capability management, business development, and so on. Okay. The forum provides to you a description that is a text description of what is this process doing, and some relationship, high-level relationship with other aspects, such as a process may be connected with a aggregated business entity, that is a information model entity, and can be also connected with a metric that is measuring the current life cycle of the process. But as you can see, this is a static model. So what is that we have done? We have taken this model and we have submitted that to a EA, and we have worked with the EA to generate a behavioral model. So what is a behavioral model? Behavioral model is a model of events. And as you can, guess, if we start with strategy management, we can think about those processes moving across up to billing. And that is what we wanted to visualize first, and that is the result. So that is a valid BPMN process that has been full generated by AI. So what we have done is we have input in the AI the process description, plus the fact that each of those processes is connected to a ABE that is part of the original model of the forum. So like the customer readiness and support process produce the customer statistic ABE, and then that is the only process in the customer domain that is in the operation readiness and support. Then we go here to fulfillment, and we have the customer interface management that produce customer party roles and so on. And here we have also introduced some additional feature, such as a decision point. For example, we have here a process called customer problem management. Now, a customer problem management is only relevant if we do have problems. So, and here we have introduced this condition, customer issue. So if the customer has issue, then we will go there. If not, we will continue to interaction management. And similarly, here we have manage customer debt collection. So if the customer is directly paying, we don't need to send hey, you have not paid, and we can go here, and just in case the customer is not paying, maybe we can, invite him to pay by doing some discounting. Again, all of that is not necessarily what the forum say. That is the modification or the simulation that we are doing of the Eurocom interpretation of this set of business processes. Now, what is that we can do with this? First off, those are very high-level processes, so the people that know better ETOM will understand that we may need to further define those processes by creating BPMN processes inside those processes. So in ETOM, we have different levels of processes. There's a level 2 process. We could have a inside level 2, a level 3, a level 4, up to level 7. But for the sake of the demo, we are good. So what we can do is we can discuss this and see if that makes sense or not. But that is not very interesting. What can we do better is simulating this. And that is a feature of EA that exists since a while, but is widely, underestimated by many users, including business users. So the ability to simulate. So what is that we can do in a simulation? In a simulation, we can establish simulation parameters. And you see here we have two different scenarios. And what is a simulation parameter? We can assign to each of those processes things such as a cost, time, resources, for example, people, and so on. And depending from those parameters, the result of the simulation will be different. Now let's look at what we can do with this. So that is our simulation is already configured, and I will execute it. So the simulation works in Java. So you export the simulation in a Java engine, and then we'll run with the simulation parameters. Now, the first thing that you can see, and hopefully you can see it because the numbers are super small, is the small number in red here. So that is the amount of steps that we have processed in the simulation. And we have instructed the simulation to perform 10 steps, so 10 cycles. But you can see that in customer readiness and support here, we process 10, but in the next one, we process only 5. It's like the customer interface management activities is unable to process 10 because we have not enough resources. And here we process even less. You see 4. And then here we have, the customer issue. So we still have 4 steps. And this time we don't even have a single customer problem management. So, and that is calculated in a statistically way. That means we assume that every 10 processes, at least one has an issue. So, and this time we had 0 issues. Now, what is that we can do is we can perform another simulation with another parameter. So that is with less resources. Let's try with more resources. We load the simulation here. We execute it. Now, check out the difference. You remember originally here, we were able to execute 10 steps, but in the next passage, only 5, and here we are already improving it. So, and we go to 10, 10, 10. Here we have an issue, we solve the issue, and we continue. But here we have another bottleneck, clearly, because we cannot process all the customer interaction management. We only have 7. Still is better than it was before. Here we have 5. Here we have 4, and so on. So at the end, with the second scenario, we only have 3 before we end the process. So over 10 iterations, only 3 are completely processed. Now, what we can do is also review the results. And you see here, we have the ability to load results. So that is the simulation after optimization, and that is before optimization. Additionally, we can also, in this UI, focus on costs, and we see that, before the optimization in the assurance division, that is a resource, we had substantial higher costs than after the optimization. That is kind of cool, but it's not really helpful to visualize things. So we have also a simulation result dashboard. So that is the simulation result dashboard, and we start with the cost. So as you can see, we have here resources, but we have warehouse workers, we have operation readiness and support resources, we have the fulfillment division, the billing division, and the assurance division. So, and you can see the two blue and red, and we can see that, while we have improved the amount of iteration that we can do, we have not necessarily saved money, because the red one here, like in fulfillment, is double so expensive. So that can help out to decide, take decision even before we deploy any process. And that is a substantial part of the digital twin. Remember, we expect that the simulation is a realistic one. Right now, what we are looking at is only a demo, so we don't claim that to be super realistic. But let's assume that we are happy with a certain configuration of the simulation, and then we want to deploy that. So we have seen how we can generate processes, how we can simulate that and do the simulation result. The next thing that we want to do is to generate a Swagger file from the exact model that we have in the TM forum. So we have used, again, EA to do that. This is the result, and is 100% generated by EA. And by the way, the TM forum has its own APIs, and they are, manually created. This is completely generated from the process. Not only we have generated the different, verbs like post and get, we have also generated all the models. Now, think about that. Really, ABEs are not necessarily the best information model, because conceptually are only aggregator of all the information. So underneath a ABE, we have a lot of business entities. So A is for aggregated. But as you can see in the Swagger, we have the complete documentation of the process, and then we have the valid, definition of all the ABEs that are connected to the process. Now, next, we take this API definition and we can generate an application. That is nothing new. It's a technology that we know we, use since a little bit, because, a Swagger is a very good definition that a machine can interpret so that we can generate a full-fledged application. And this application is really deployed on the web. And that is what we are going to use in our digital thread. So let's jump into the model. So what is the digital thread? So we have 4 processes here, and you can see that those processes are processes that contain all the information of the TM forum. If you are familiar with that, we have information such as process identifier, that is the ID here, the name, the description of the process, and so on. But we have also additional information, and that is the second meta model that we have applied to this model, and that is what is required to do digital engineering. Now, in this sense, what is important here is the criticality. And when we deploy the application, criticality is something that we can query, and we will get a response directly from the web by querying the criticality. Additionally, you will see that the model here, you see the criticality here is 88, will be updated in real time. So what I do is I press the button here, and you see we are really querying a API, And by the way, that is completely model-based, so no external software is required. And you can imagine that the ability to query directly any API from the model without deploying any additional software is really powerful. And we are getting the new value of the criticality for this process. And in here, what happened is that the criticality is updated. And every time that we trigger the process, the criticality is updated. Now, this is clear, it's a real application, but the calculation of the criticality is kind of calculate with an algorithm that say that criticality can have a certain variation. So you can see that it's not completely random. If here we have 82, can grow a little bit or decrease a little bit, like now 5. And all those processes here are now in sync with the model. So that means that while we are defining the model, we get immediate feedback from the real field on the performance of this model. Currently, it's only one single property, but you can imagine that we can extend this concept to a lot of different properties and measure them and aggregate all of them. Okay, so we have demonstrated that we can take a Eton process, transform this process in a Swagger directly with the process description and the business entities or aggregated business entities that are connected to that, transform the Swagger into a application, and we have demonstrated the special technology that we have created at Door Business Consulting to establish a digital thread with your model. Now, the next thing that you want to do is to create a dashboard that can monitor all of that. We are using Grafana here, and Grafana is an open source tool. It's not originally supposed to be used in this way, but we don't care. What we want to do here is simply to show some information. All this information is coming directly from the model. As an example, what I'm going to do is check out those numbers. I'm going to move this one here. So I will start now the digital thread. And as soon the new information is coming, you can see that the process health here is updated. And then we have the overall health of the domain. So this is created live from the model by aggregating all the health of the different process in a single number that we can, evaluate. Another thing that we are doing is, you remember that we have assigned resources to the process. So is aggregating all the resources of the process, and based on the current scenario of the process utilization, we know that right now our resources are utilized only 36%. That is frankly very low, and that's why we are on red here. Another thing that we are calculating live is the domain cost. The domain cost is aggregated with meta information that are directly linked to all the applications that are part of the domain. In this case, the visualization will show that in customer domain, we have more application than in any other domain. Again, all this information is live in the model. We could, delete from the model half of those applications and see immediately this dashboard updated. Another thing that we want to do is to have KPI that will calculate the current, quality of things, such as business benefit are being realized, delivery organization benefit are being realized, risk has been mitigated. All those are aggregated KPIs. That means that is not a single KPI, but it's a KPI area. And we have in the model several factors that we are evaluating. And here in Grafana, we are, out of the box, aggregating all this information, displaying as a single number. Finally, so those are quality API that are not necessarily related to the single process, but the overall, quality of your, methodology or how you execute things. And finally, we have those other KPIs. Those are, again, TM Forum KPIs. So for example, aggregated to or related to customer problem management, we have the number of customer problem reports. And you see here we have two dimensions. So that is the current number, and that is what we expect to be good. So, and here, for example, we have a number of problems that are initiated by customer. I'm sorry, here is cut the label, but we don't want, the customer to discover problems. We don't have enough lot of numbers, customers deal with errors. So that is a inverse KPI. That means if everything is green, it's very low. And we have an average number of bills that send electronically and so on. So to do that, again, we have taken the standard metric from the TM Forum, and we have added to that metrics additional key performance indicator concepts so that we can calculate, for example, the difference between the current level and the satisfaction level. Okay, and so let's conclude this presentation, and then I will have some time for questions. So what is the conclusion of all of that? Very often when I try to present those ideas in different situations, there's a lot of pushback, and typically the pushback is for the tools. You see here, that is a model-based system engineering tools, and that is, by the way, a research that has been paid by the US government. The US government believed that, especially the DoD, digital twin and digital engineering is the way to go to win the competition with so-called adversary states, because can accelerate a lot the creation of technologies. But as you can see, the tooling is really the last of your issues. The real issue very, very often is leadership. So if leadership is not support and commit to the transformation and help out with everything else that will follow, this digital twin idea is not going to work. Digital engineering is not going to work. And very often leadership believe that all the stuff is technical stuff. And they believe, oh, we don't need to do that. Or, oh, you techie guys, you will, take care of that. That is not true, because we need to change the culture of the organization. For example, one thing that we need to change is the fact that we want to have high quality results. I remember having a client here in Canada, and from one side, leadership said, hey, we want to do this thing with Sparx and industry models. On the other side, we want you to be ready yesterday. And they started to take shortcuts, and the results were not high quality. So if leadership don't understand that high quality in long-term pay off, there's nothing that the people in the field can do to help. So leadership need to provide clear communication of the reason and the needs for that. Also provide a path of training and mentoring to people that are, lacking of the skills. Creating a model is much more complex than creating a diagram that is a picture or a PowerPoint or a Excel spreadsheet. It requires a lot of training, but even better, mentoring, so training on the job. Another thing is that should relate to the culture of the enterprise, and people that are doing the right thing need to be recognized and rewarded. And overall, we need to review all the different processes that we use and to understand how also things that are apparently unrelated can be affected by that. As an example, you see here we have some stuff that is very business related, but if you think about those KPIs, that is project management. So we need also to rethink project management. We need to rethink our JIRA stuff. We need to rethink how we do strategic thinking. We need to rethink how we create applications. So it's a general change of, the organization, and that need to start from the very top. And with that in mind, I think I am in time. We have 15 minutes for questions. Any question?
So thank you, G. Platina, for the wonderful presentation. So we have a question from Robert. What are some best practices to handle two different industries which are dependent on each other in a single model?
This is an excellent question. Unfortunately, we don't have a single strategy for the creation of models across industries. Each vertical here, by the way, I have hand-on experience with most of those systems, and they are really, really different. Would be very nice if they will sit together and they will create a single standard for the definition of what is a industry model. Because they are so different and they come also in different formats. For example, some of them, they still come as a Excel spreadsheet. That is an example, APQC. It's up to you to try to normalize those models and to keep those models, together. However, interesting enough, this is a model in which I maintain a lot of different industry models. And you can see that here, this model with the enterprise continuum, the one that are familiar with TOGAF, probably remember about the enterprise continuum. The enterprise continuum contained something called industry architecture. And as you can see here, we have a lot of them. So we have Accord, that is insurance, arts, that is retail, buy-in, that is banking, CIM, that is for energy and utility, and so on. So it is possible, but clearly add a lot of complexity to your own model and will require, special care. Thank you for the question. That is a good one.
Thank you. And we have a question from Ryan. Can you comment on your use of AI in this example? You mentioned it, but it was unclear what role AI played.
So really, I was thinking about how to show to you what we have done, but it's a lot of code. So what we do is we take a model, we expose this model as a XMI, so that is a XML version of it, and then we can use the Eclipse environment. If you remember the tool set. So what we do is we export the model that is in the repository into Eclipse, and then in Eclipse, we can either write directly transformation or use the API to different existing models. For example, ChatGPT is one that you can use, or you can directly write transformations by using machine learning. So, and that is what we have done, the two things in different cases. So in the case of the transformation between the Eaton process and BPMN, we have used ChatGPT to do that. And in the case of the API, we've used a transformation that is written, by us and by using our own machine learning framework.
Okay, so we have a follow-up question from Ryan. Top-down mandate is great, but not realistic in many organizations. But do you have any suggestion on how to achieve results in an effort like this, being driven from the middle of the corporate hierarchy?
Sorry, can you repeat the question?
Yeah, sure. Top-down mandate is great, but not realistic in many organizations. But do you have any suggestions on how to achieve results in an effort like this, being driven from the middle of the corporate hierarchy?
So top down has very different, meaning. I mean, you can start top down in a part of the organization and start building. You remember that we said that a digital twin can be composed by multiple, digital twins. So it's a system of systems. You can start top down because you are, the leadership in charge of this SCADA system, and you create your own digital twin of this one. You demonstrate success, and then you submit your success to, IT, and you start to create fast digital twins of all the system, physical system or IT system of IT, and then you go and you start creating also social systems if you want. That is the complete Eurocom. There is no single, way to do that. It depends a lot on what is the maturity of the organization, what is their need. Typically, successful organizations are more difficult to transform that failing organization, because when you fail, you have more need to change that if you are successful, and no one is recognizing that we need to change certain things. But again, it depends a lot on the situation.
Okay, and we have a question from Martin Sharp. Could you comment on my assertion that a correctly constructed and used architecture model is in fact a form of digital twin?
It may, it's a matter of definition of architecture, okay? I am doing architecture since many, many years, and very often I'm asked, okay, can you define what is architecture? And I get a variety of responses. So the architecture must be a model, and this model has enough properties so that we can create an instance of that model. That instance of that model need to be testable against the real thing, and the result need to be the same of the real thing. And again, here I have the example with the whole organization, but think about the SCADA system. If your architecture of the SCADA system is so good that you can, send a test to the architecture, get the result, and if you have a SCADA system that is working, you get the same result from that, then you have a digital twin. In any case, good architecture is foundational for the creation of the digital twin. However, and now I use a technical term, the main difference is that the digital twin is an instance. Architecture typically is a blueprint of things. So don't necessarily define the instance. The digital twin is a specific instance because you have all the variables that are instantiated for that specific digital twin. And you can create several instances. That is basically what we have done with the simulation. But if you only have the blueprints, so the architecture, you don't have necessarily a digital twin.
And we have another question from Ryan. What do you see as the key use cases for an organization to do something like this?
Without trying to convince anyone, I can only say that the original, motivation is the following. The DoD, the American Department of Defense, once was able to design, build, and deploy a aircraft within 1 year. And that was during the Second World War. And then the increasing complexity of the aircraft being a system of system that today is based on software and hardware, and the way in which they work together, took that to the level of the F-35 that required almost 25 years from the very initial design to the first, flying airplane. And Similarly, also, business organizations need to manage complexity, and by manage complexity, they can, accelerate innovation, break bridges, and have a agile growth. So that is the motivation. That is why I'm saying that need to start from the very top, because there are costs associated to that. There are changing culture that is associated to that. So there's nothing that typically happens because a bunch of clever people in the architectural team decide to do that, at least not in scale. You can have islands of excellence, but the real issue that we are trying to solve here is a major issue of today's organization. Thank you.